to physics class 9. The chapter is 2, second chapter, part C, third part, where it is equations of motion we deal. One is graphical method and one is a non-graphical or conventional method. Either of the way you can. So here the graphical method. And this graphical method, we know that it is a uniformly accelerated motion. So we take the graph. That graph type is velocity time graph, which is a very versatile graph, you know. The last day we dealt with it, because it can give us many informations. It is velocity time graph. Obviously, velocity being the dependent quantity on time, so that will be on y-axis and time will be taken on the x-axis. Then this graph is being drawn in that in 0 time at point O, that is the origin, it starts with the initial velocity as a u. So I have written initial or starting velocity. The body starts moving with initial or starting velocity of magnitude u with the corresponding units. Then this velocity keeps on increasing. Which way increasing? It is increasing so that it forms an inclination. It forms an inclination. That means it is an accelerated motion. This graph line A to B shows the accelerated motion because there is a change in velocity. This change in velocity changes from u magnitude to v magnitude. The whole of this is v. As I have written on top there, the final velocity happens to be v. So this body moves to the velocity b. For this change, it takes the time from 0 second to t second. From 0 to t, it takes the time. So time taken for that is t second. Distance moved as a whole will be s. We'll say what time the distance we'll find. And the acceleration produced, because there is an acceleration. Because it is changing the velocity from u magnitude to v magnitude. If the u magnitude is less than v is greater than u, there will be always an acceleration over the period of time. That's why this is 1. Now we go by geometry, simply by geometry. Geometrical way that we find in here that slope of the graph. Therefore, slope we know it should be ordinate by abscissa, the same term we are using. So what is the ordinate value here? The slope we can find from B to C, that is the slope, divided by abscissa value is AC, so it is AC. This gives us, slope gives us ordinate by abscissa. By units, the other day we found the units, from there we came to know slope is nothing but the acceleration. That is velocity time graph, the slope shares the acceleration. So BC, this BC length is actually BD minus CD. BD minus CD whole divided by AC. What is the BD length? BD length is complete V. BD length is complete V. So A is equal to V minus U. CD is U. It is a rectangle formed here. So this CD will also be value as U as magnitude, as it is the initial velocity 1 divided by time. So it is our known form. Acceleration is V minus U by time, which denotes ultimately that V is equal to U plus AT. That is very common and very known formula for us. When you interchange by cross multiplication, you will get this relation. So relation number 1, final velocity is equal to initial velocity plus acceleration produced over the period of time, over the time, that is t. So altogether it is V is equal to U plus AT. First relation. We move on. The informations taken here in the same diagram. In the same diagram here, Distance traveled. Distance traveled, I have just given a symbol here as S. So distance traveled distance traveled is area under the graph. What is the graph area here? This is the graph area here. I'm just shading it for your. This is the total area which is covered by the graph line. Total area is this. This total area is falling on the time axis. That's why area under the graph. This much area, this much space is a combination of two figures. One is triangular right angle triangle figure ABC. Another is ACDO, that is another rectangle. But the figure as a whole is a trapezium. A trapezium is the quadrilateral with two parallel sides. So this trapezium OABD as a whole of the trapezium is having OA side parallel to the BD side. So this is a complete enclosed figure called a trapezium. So this will be called area of trapezium. Formula for area of trapezium is 1/2 into sum of the parallel sides multiply with distance between the parallel sides. In words we say the sum of the parallel sides multiply with the distance between them. Distance is called sometimes altitude, sometimes height, but here is the distance I am meaning it, and that will be constant for, and divided by 2 as a whole, call it is area of trapezium. So then as we say S is equal to, what is the distance for BD? Parallel sides are BD plus AO. 1/2 into BD plus AO. That is S is equal to 1/2 into BD length. Whole of BD length is nothing but V plus this is side called U multiply with the distance between this is O to D, that is OD. That is OD. Space is very less, you just manage OD. That means this distance OD is actually called time. So thus we get S value is equal to 1/2 into V plus U into this T value can be taken from equation number 1. T value can be taken from equation number 1. It will be V minus U by A. By eliminating T, it is V minus U divided by A. So it comes in here. S is equal to 1/2 V square minus U square by twice A by A. And ultimately, when you again cross multiply, you get a relationship that is twice AS is equal to V square minus U square. And likewise it is V square is equal to U square plus twice AS. It is the second equation called, it is the second equation that is called the equation of motion. The first equation, V is equal to U plus AT. First equation, V is equal to U plus AT. V means final velocity, U means initial velocity, A is acceleration produced, and T means time. And the second equation we got V square value is equal to U square plus twice AS, the second one we got. I have to rub this part for our next section of work to be done. The same formula we start with, that is third time. Again, S is equal to the same formula we are using, 1 by 2 into BD plus AO. Here is BD plus AO multiply with OD. Same formula. That is area of trapezium we are taking in. Therefore, S is equal to 1 by 2 into, that is V plus U multiply with T. The time we eliminated T as V minus U by A. Here we eliminate V. V means the final velocity. The final velocity formula from equation 1 refer to this. It is what? V is equal to U plus AT. That's why we'll eliminate U from there. That is S is equal to 1 by 2. V is U plus AT plus U as it is multiply with T. This shows S is equal to 1 by 2 into U plus U twice U plus AT whole multiply with T. This gives you S is equal to 1 by 2 twice UT plus AT square. That means S will be